Hello guys, I'm Darshan. I'm studying first year engineering in SVC college and I'm here to explain about optical fibers. Optical fibers are the thin strands of glass or plastics that are used to transmit the light signals over long distance. And they are also the key technology in telecommunication, internet connectivity, and various other industries because of their efficiency and also speed. And this is a structure of optical fibers where we can see the core and it's surrounded by the cladding, coating, and the outer jacket. Uh, Mainly, there are three structures of optical fibers. First, firstly, core, the innermost part where light travels, and it's also made up of high purity glass or plastic. Secondly, the cladding. It surrounds the core and reflects back the light into core, preventing it from escaping. And the buffer coating is also structure which protects the fiber from damage and also moisture. Here we're gonna talk about the attenuation. Attenuation in the context of optical fibers refers to the loss of signal strength as the light travels through the fiber. It is typically measured in decibels per kilometer, and it is a critical factor in determining the efficiency and range of optical communication systems. The signal attenuation in optical fibers is nothing but the loss of optical power suffered by optical signal as it propagates through a fiber, and it is also called as fiber losses. Causes of attenuations or the fiber losses are absorption loss, scattering losses, and the radiation losses. First, we're gonna talk about are of three types. First one, absorption losses. Absorption of photons by impurities like metal ions such as iron, cobalt, chromium, copper in silica glass of which the fiber is made of. Mainly during the signal propagation, the photons interact with electrons of impurity and atoms electrons are excited to the higher energy levels. The electrons and atoms which are excited have given up their absorbed energy either in the form of light energy or the heat. The re-emission of light energy will usually be in a different wavelength, hence it's also known as loss of energy. The other impurities such as hydroxyl ions which enters into the fiber at the time of fabrication which causes the significant absorption loss. The absorption of photons by the fiber itself, assuming that there are no impurities and inhomogeneities, it is also called as intrinsic absorption. Second type of fiber losses are scattering loss. The scattering of a light wave occurs whenever a light wave travels through a medium having scattering objects whose dimensions are smaller than wavelength of the light. Similarly, when a light travels, the signals in the fiber, the photons may scattered due to the sharp changes in refractive index values inside the core over the distance, and also due to the structural impurities present in the fiber material, and this type of scattering is also called Rayleigh scattering. Scattering of photons also take place due to the trapped gas bubbles which are not dissolved at the time of manufacturing. Scattered photon moves in the direction in randomly and leaves the fiber. Of fiber loss is radiation losses. The radiation losses mainly occur due to the macroscopic bends and the microscopic bends. Firstly, we want to talk about the macroscopic bending. It means all the optical fibers having critical radius of curvature provided by the manufacturer. If the fiber is bent below the specification of radius of curvature, the light ray incident on the core cladding interface will not satisfy the condition of total internal reflection. This causes the loss of optical power. The second bending is microscopic bending. It means the repetitive small scale fluctuations in the linearity of fiber axis. They occur due to non-uniformities in the manufacturing and also lateral pressure built up on the fiber. They cause the irregular reflections and some of them leak through the fiber. The defect due to non-uniformity or the microbending can overcome by introducing the optical fiber inside a good strengthened polyurethane jacket. So this is all about the attenuation and the fiber losses. Thank you.